Back up with number 19. We're going to find positive and negative coterminal angles. All coterminal angle means is they start and stop at the same place. And there was a way that we found that. It was always plus or minus 360 degrees, or plus or minus 2 pi if we're in radians, but it looks like both of these are in degrees. So if we do number 20, if I want a positive coterminal angle, one thing that could be easy to do if I add 360 to the 15, because then I'm going to go, 15 degrees is really teeny tiny, but if I want a coterminal angle, I say, okay, well, I'm going to go 360 plus that 15, and now I'm back at the same spot. And so that would be 375. If I want a negative one, just go in the opposite direction. We want negative 345. So there's positives and negatives. You could keep finding them. You could keep adding or subtracting to get positives and negatives, but we have to just make sure that our answers are in the multiple choice problems, since your final will be multiple choice. The same thing with negative 435 degrees. There's going to be one slight little problem with this one, though, and I think you see it, or you'll see it in a second. If we take negative 435 and add 360 to it, we get negative 75, which is a problem because that's still a negative 1. And if I subtract 360 from this, if I go negative 435 and then minus 360 more, I get negative 795. So both of these are still negatives. I need to get a positive number. So what I'm going to do is I'm just going to keep adding 360s. What if I add one more, then I'm definitely in the positive area. Let me erase this over here. If I add two 360s, then finally I get into the positive numbers. So it could have been these two, you could have done this one and this one, either combination. You just need one positive and one negative. So if you add 360 and it's not positive yet, add another one. You have to keep adding and subtracting until you get one of each. All right, converting back and forth, 21 and 22. It just depends on which form you're wanting, what you multiply by. We either multiply by pi over 180 or 180 over pi, and it has to do with what you're trying to get. 21, I'm trying to get it into radians, so I'm going to multiply. I need a pi to show up, so I need a pi to be up top. I need it to be up top. 22, I'm trying to get rid of radians and put it into degrees, so I'm going to move the pi to the bottom, because then I'm going to get the pi's to divide out. There's going to be one on top and one on bottom. So let's see. If I multiply 21 by pi over 180, then I get, 195 pi over 180. But I'm going to simplify pi, or simplify the fraction on my unit. Oh my goodness, I can't talk today. I'm going to simplify the fraction using my calculator. I'm going to enter in how we would do it. We'd get 195 divided by 180, and then we're going to do math frac. We're going to simplify that fraction on our calculators. Leave out the pi, because the pi is going to screw it up, but just simplify the fraction, and we get 13 pi over 12 as our answer. So 195 degrees is really 13 pi over 12. That's what it's going to look like. On 22, if we're going to try to get it into degrees, I want to get it out of radians, I have to put the pi on bottom so they divide out. Because now I just need to do 49 times 180 over 18. And if I enter that in, if you put it on your calculator, top part's got to be in parentheses because you have two pieces, then I'm going to get 490 degrees. I have my final answers. So maybe these conversions we write on our unit circle to help. Pi's on top if you want radians, pi's on bottom if you want to divide out the radians. Okay, 23 and 24, probably the easiest two on the whole review. They're just legitimately calculator problems, but the biggest thing that's not on your review is you need to be in the correct mode. This is where it does matter. All of our triangle problems are all degree mode because we had degrees given to us. And this is different here. 23, it says tangent of negative 171 degrees. That is a degree mode problem. But 24 has 26 pi over 9. That is definitely not, and I'm going to have to switch it back to a radian mode to get this answer. Round it to 4 decimal places, we just type it in. So really, if I do type in tangent of negative 171, if it's in degree mode, I get 4 decimal places, 1584. Here's my answer. A little bit different from 24. If you notice your calculator, you do not have a cosecant. I don't have a cosecant. So I'm going to have to enter it in with its reciprocal function. I know that cosecant is 1 over sine. So I can enter in 1 over sine of 26 pi over 9. And on the calculator, it would really just look like 1 divided by sine of 26 pi over 9. Put it in. I need 2 decimal places. I need 4 decimal places, so I get 2.9238. That's that one. If you get something that's like a cosecant, we know from this cosecant goes to sine, secant goes to cosine, and cotangent goes to tangent. So you can always enter in the reciprocal instead. Alright, so let's not panic when we see 25 through 30. Yes, you're going to have to find some type of trig function. But all of these are grouped together. You have 6 because you have one of each trig function. On your test, you won't have one of each. I can definitely take off some of these. But we're going to at least try to find each one on our review. And here's the thing. Use the point to find the value of the indicated trig function. So we're trying to figure out, okay, cosine or sine. Here's the deal, though. None of the points are on my unit circle. None of them are. So I can't just say, oh, cosine is x. There it is. No, I can't do that. Or sine is y. Oops, that's not y. There it is. I can't do that. I have to use my other identities that I have on the back of my unit circle page. I have to find r. I have to find that radius. So this is where we always did x squared plus y squared equals r squared. And we know r squared is always r is always positive. And we need to find this piece in order to do it because cosine is actually x over r. Sine is actually y over r when I'm not on my unit circle. Cotangent is still x over y. Tangent is still y over x. But secant, it's not 1 over x. Now it's r over x. Cosecant is not 1 over y. Now it's r over y. And we have to be able to find those. So we have to find r. And the reason why I know I have to do that is because I am not on my unit circle. This is farther off. And so we can find that. If we were going to test out, say, 25. Let me erase this so I have a tad bit of space. So 25, I need to find r. So I'm going to have to try x squared, so square root of 13 squared plus negative 6 squared equals r squared. So let's see here. We get 13, I just take the square root off, plus 36 equals r squared. Well, conveniently, that is 49. So r is just 7. Got it. R is just 7. So I need to find cosine, which is x over r, which will be x. Square root of 13 over 7. There we go. As long as I find r, I can find any of these. If you kind of notice, 2 of them are going to be a piece of cake. I'm going to skip around. 27 and 29. Cotangent is x over y. Tangent is y over x. I don't even need r. If you want to find it, if you want to test to see if you're really good, it should be 6 for 27 and the square root of 410 for 29. And I'm sure that reduces somehow, but this is ridiculous because the only thing we really need to do is say this is x over y. I have square root of 11 over 5. And y over x, negative 7 over negative 19, which gives me positive 7/19. So if you get a tangent or cotangent, consider yourself lucky because you don't have to do any extra finding the r on those. But the other two, we can do this. So let's try. If we need y over r, let's try to find it. I know negative 3 is going to have to be on top. We just need to find r. So if we have 4 squared plus negative 3 squared equals r squared, we can find that. It looks like I'm going to get 16 plus 9. If I take the square root of that, I get r equals 5. So I get negative 3 over 5. That's a 3, 4, 5 triangle. Let's try secant. Try to find r by yourself. See if you can get r by yourself. See if our answers will match up. So maybe pause the video, try to work it, see if you can get it to match up. Alrighty, so 28 is probably the most detailed one. To find r, I square both of those pieces, add them together, take a square root, and I'm going to get, you can kind of see the work, I'm going to get r squared is 100, so r is just 10. And if secant is r over x, then I get 10 over negative square root of 19. And we can't have those square roots in the bottom, so we're going to multiply top and bottom by square root of 19, or negative square root of 19, whichever one. And we're going to get negative square root of 10, negative 10 square root of 19 over 19. I'm stumbling over my words in this one. But that one's the most work required. 30, we already did 29. 30, this one's not going to be too terribly hard. I'm going to take negative 2 squared plus square root of 5 squared equals r squared. Looks like I get 4 plus 5 equals r squared. R is going to be 3. So if I need to find r over y, it looks like I get r over y. So 3 over square root of 5. Can't leave the square roots in the bottom. We're going to multiply top and bottom by that square root. And I get 3 square roots of 5 over 5. So each one of these we have an answer for. Not every single one did we need to find r. We didn't have to do that. You remember tangents and cotangents, we don't have to. But if you get a point that says find the trig function, and that point's not on my unit circle, we have to find r. We have to find it. So maybe somewhere around these problems put find r, maybe on your unit circle, given a point not on the unit circle, find r. You could write that next to your identities. You already have these on your page, whichever ones. Whatever you feel like you need to write down, go for it. Okay, 31 and 32. Probably when we took tests over these were the most missed problems of the semester. And it's not because they're super, super hard. It's because of our second piece. It's after the and. This is the part that messes us up. But we know what to do. We know what to do. This one, given all this stuff, find tangent. So eventually I'm going to have to figure out a y over x. On 32, it says eventually find cosecant. So eventually I'm going to have to find r over y. I can do that. I know these have to have the r's included because these fractions that I'm seeing, I don't see these fractions on my unit circle page. And so what we're going to do is these clues at the beginning, they're going to give us a few pieces of info to help us out. So let's see here. I know for these I'm going to have an x and a y and an r. I can find all these pieces. So let's see here. Cosecant is negative 5 over 3, and theta is in quadrant 3. Got it? Find tangent. Okay, we can try this. So cosecant, I know, is r over y. And one thing I do know about r is always, always, always positive. So this negative, it actually goes down here with the 3. Notice it's just in front of the 5/3. It can't go up with the 5 because that 5 is a positive 5. So I know that y is a negative 3. Y is a negative 3, r is a positive 5. Here's where we would get tripped up because of this piece over here. Theta is in quadrant 3. So I don't know x. I can find x, but theta is in quadrant 3. What that means, what do we know about quadrant 3? I know that x is negative and y is negative. Well, we know y is negative. Just look over here. We got a negative y. But we have to figure out x. And when I do, I know it's going to be a negative value when I find it. So we can find x. We're trying to figure out x squared plus y squared. Put that negative in parentheses. Equals r squared. So I get x squared plus 9 equals 25. Oh my goodness, I'm pretty sure this is a 3, 4, 5 triangle. So I get x equals 4, and I'm going to put a negative in front of it. I know it has to be a negative 4. It says theta is in quadrant 3. Look at that second piece. Now the problem's really easy because we're over here now. If tangent is y over x, then tangent's going to be negative 3 over negative 4. Tangent is 3/4, positive 3/4. I get double negatives. I'm in that quadrant. So it's not that the problems are super hard. We just have to remember to look at all of the pieces. Same thing with 32. Let's see here. Find cosecant when cosine is 7 over 25 and sine is less than 0. This means sine is negative. That's what we have to do. Make sure we don't get those backwards on our test. So let's see if we're trying to find x, y, and r. I know I need all these pieces. Cosine is x over r. Alrighty. X over r. We can do that. If I know r is always positive, r has to be 25. And that means x is going to be 7, and it would have to be a positive 7 for that whole fraction to be positive. It's got to be a positive 7. So one thing I'm trying to find, I don't know why, but the variable, but I do know because of this second piece, pay attention to it. I'm going to be obnoxious about that second piece. It is negative. It's less than 0. So we're going to have to figure out what this y value is. So I get x squared. I do know x, sorry. I'm looking for y squared. X squared is 7 squared plus y squared, I don't know what it is, equals 25 squared. So let's see, that's 49 plus y squared equals 625. If we subtract off the 49, we're going to get y squared equals 576. And if we take the square root, y is 24. But because of this piece right here, we're going to make it negative. That has to be a negative 24. Now I have my pieces. If I go back over here, it says we got to find cosecant. Cosecant is r over y. So I'm going to have 25 over negative 24. There's my answer. Moral of the story for these two problems, do not ignore this second piece. It's going to tell you something about positives or negatives in your problem. So we got both of those pieces. X, Y's, and R's still on these because I'm not on my unit circle. And the last two for this video, we're trying to do in equal kind of spacing chunks. We're just finding amplitude and period for each function. And maybe these are some some formulas you're going to write down somewhere in your unit circle page. Amplitude is the absolute value of A. A is the number that's in front. And then period is 2 pi over b. And I'm going to there was another one. Pi over b was for tangents and cotangents, but we're not going to use this one. Notice that we just have sine and cosine. So we don't need to worry about any crazy period formulas. And so the two numbers I need A, I need the number that's in very, very front, and I need B, the number that's in front of the theta, in front of the x. So if I'm trying to find the amplitude for this first one, amplitude is absolute value of that number in front, so the amplitude is just 3. And the period is 2 pi over b, 2 pi over 2, so period is just pi. So I got my two answers. 34, amplitude is just 1/6. We have that one. The period, my b value is not 7, it is 1/7. It is dividing by 7. Dividing by 7 is really like multiplying by 1/7. So when I try to find period, I have to do 2 pi over 1/7. And instead of dividing by fractions, because we don't do that, we multiply by reciprocals. So this is really like 2 pi times 7. My period is 14 pi. It has stretched this thing out a lot. So even if you have something crazy that looks like this really crazy fraction, don't worry about it. We know if we have something over a fraction, I'm just multiplying by the reciprocal. So maybe from this video, we add things like the amplitude and period function. We talk about x, y, and r. There's the bell. Or other things that came from our trig sections. We just have a few more problems left. We're going to get started on our graphs in the next video.